The spin is a fundamental property of subatomic particles like electrons, and it's responsible of the magnetism of atoms and molecules and materials in general. The quantum nature of the spin makes possible to realize qubits starting from magnetic atoms and molecules, and qubits are the single memory unit of quantum computers. In the Laboratorio of Molecular Magnetism, led by Professor Roberta Sessoli in Florence, we are developing single qubits starting from molecules. There is a special class of molecules called single molecule magnets that behaves as tiny memory units. The magnetic memory in these molecules is preserved thanks to the existence of an energy barrier that divides the north pole and the south magnetic pole of the molecule. The quantum nature of these molecules allows directly crossing this barrier without jumping it by the tunneling effect. Today, we can control this inversion thanks to the realization of a hybrid material composed by single molecule magnets and a superconductive metal surface that is lead. This kind of control is possible thanks to the use of particular instruments that are capable to reach ultra-high vacuum condition, that is the condition that we can find in space. The use of this instrumentation allows the realization of a high-purity lead surface on which we deposited a single layer of magnetic molecules. Lead is a superconductor at very low temperatures and below a certain magnetic field value. In these conditions, lead progressively screens the external magnetic field thanks to the superconductive currents that are flowing inside its bulk. Thanks to the use of synchrotron radiation, we observed that the progressive transition of the superconducting lead surface activates the switching of the molecular spin thanks to the activation of the quantum tunneling process. This means that a single molecule magnet behaves as a magnetic sensor for the superconductive transition. These results, obtained in collaboration with Italian and European research groups, represents a new frontier for the realization of different hybrid materials and for the development of novel quantum technologies for information.